Hey there, hackers. This is LeetCode 1161, maximum level sum of a binary tree. This is a medium level problem, and the solution we will cover today is recursive depth first search. Let's begin. So we read this tree from top to bottom, left to right. So 1, 7, 0, 7, negative 8. And yeah, 1, 7, 0, 7, negative 8, null, null. And that means that there are no nodes that exist in these two places. Yeah, and I think you have to write out the array for every level fully. So that's why we add the nulls there. The level 1 sum is 1, the level 2 sum, 7 plus 0 is 7, level 3 sum, 7 plus negative 8 is negative 1, and we return the level with the maximum sum, which is level 2. So I drew out the graph for us here really quick, and I number the nulls. So this is null 1, null 2, null 3, null 4. And we can see that the root is 989, and if we go over here, that we're going from top to bottom, left to right. So 989, null 1, 10 2050, 10 250, 98693, negative 889 388, so on and so forth. And if you draw it out and you look at it, you notice this null. There's a null here. So basically, the node that was connecting this subtree to the root is basically been cut off. So this entire area here, like, basically doesn't exist in our tree, you know. Or these are, yeah, they've basically been cut off from our tree. They've been pruned from our tree. And so the only actual tree is this 989 and 10250, because this is empty space. This node doesn't exist. And so, and our level 2, like, there's one vertex for level 1 and level 2, and the vertex for level 2 is higher. 10250 is higher than greater than 989. So level 2 becomes the maximal output. Alright, folks, we're gonna go over the recursive DFS solution, and I think I can make the font a little bit bigger for you guys. Yeah. So, all right. So we have this recursive DFS solution, and this is for example 1. We're going to debug this, and yeah. So we call max level sum. We create an array of size 100, because I think that was the maximum size of the tree, and then we're gonna call a DFS root depth equals 0, and I think the root that we passed in was just empty. Yeah, it was just we built the tree in Java out of I wrote a little code to build the tree in Java, and then we basically insert that into the max level sum. So okay, so we do int max val, or no, we go to the DFS, and then I think we're gonna step into here, and then root equals null. No, the root is 1. So our root is simply the our root is the top node, right? It's the thing right here. So we step ARR depth plus equals root dot val. So for 0 depth, we add the root value, which is just going to be 1, and then we do a level order traversal. So we do DFS left, DFS right, passing in depth plus 1. Let's step into here. So now we are at root val equals 7, which is right here. Okay, that's right here. So we step our depth plus equals root val. So look at our ARR. So 1 and 7, right? We got 1 and 7 going on here. Step over, and we are at so we did we DFS'd into the next level down, which is right here. So we went from 1 and we went to 7. We went to 1, 7. Oh, that's really big. 7, and now we're at this 7. Okay, and then we add ARR depth of 2. We add that. So we look at here. 1, 7, 7. This is working really clean. Okay, and then we're gonna do DFS right. So and then we step into here, and then we hit this null condition. So this thing doesn't have any kids, right? No kids here. This is where it ends. So we return here, and then now we're at root.val is 7. So that's right. So now we shot back up to here. So we're back here again. Back at this point right here, and then we're exploring -8. We're about to call root.right. So root.val is -8. So we're in this area here, and then we add that to depth equals 2. So basically we did 7 minus 8 is now -1. And we're gonna look at these 2 kids here. They're gonna come out as null null. So we're gonna have null for these 2 kids over here. Null null. So we're gonna step into root.left. That's going to return. We're gonna step into root.right. That's gonna return. And now we check these 2. And now we pop back here, right? So we're at root val equals 8, and then I think we're gonna step back up, and that is gonna be where's root val equals 1. So okay, this jump back up. We since we explored this, the recursion jumped back up to here, and so now we're at here. Back at the root, and now we're going to explore root.right this way, right? So, and sorry, my notation I know is getting messy. We step into here, we're at the root.val is 0. We add that to the array for depth 1, which does nothing, because adding 0 does nothing. So we are okay. We're right here at 0, and we're gonna check these 2 kids. they're gonna come out as null, right? Maybe I could just type it. Null. Okay. Okay, paintbrush is not obeying my orders. Okay, null, null. Right, so we're gonna step into here, it's gonna return immediately, right? And then we're gonna step right, it's gonna return immediately. Pretty simple stuff. And then where are we? We're at root val equals 0. We're gonna pop back up. And that we're gonna pop back up here, and that's gonna end the DFS. And the DFS is done now. And so now we're basically gonna cycle through the the array and find the largest sum. And if there's a tiebreaker, if there's a tie, we break the tie with the earliest index that happened. So the largest sum here is 7. There's only one clear winner here. But if there was a 7 like down, if there were like one or more 7s down this way, like 1 7 negative 1 7 7 7, then this first 7 would be chosen because we want the we want to get the level that happens earliest, and that's listed in the problem statement. So let's go here. Max val is integer.minValue, so that's just the standard min value for integers, and that's better than just doing negative 99999. Max index equals 0, and we go through if max val less than, so basically we're just trying to find the maximum that happens earliest, and this is pretty straightforward. This is just gonna go through like 100 times, right? So we don't want to go through all that. And then our max IDX is gonna be 1, since this pertains to the second levels because we have 0 based indexing, so we're gonna add 1 to make it back into 1 based indexing, and that's going to show that this level here is the one that has the maximum sum. Okay. Alrighty then. Thanks for watching. Be sure to like, comment, and subscribe. OpHaxor out.